Okay, and then all of a sudden they have terms like this. Okay, you have to somehow visualize this is not equal to 75, so on and so forth. 196 you reject, things like that. Okay, you don't know why they are doing that for. Okay, it's all in the mind. Okay, all in the mind. But if you look at this, is it simple to understand now? Yes or no? Right? I just told you what you form the boundaries of the circle, and whatever if we were to draw, there's a circle, so there's another circle, right? The invalid circle. So the invalid circle is this circle now. So this circle that I'm putting in now, this is the invalid circle, right? Why is it invalid? Because part of the circle down here, right? Part of the circle down here is outside the what? It's outside the demilitarized zone. You will go into the plastic region already, or if you're in a brittle material, you'll fail. Okay, so that is not a valid circle at all. Okay, because you're outside the operating zone, right? So now,
You froze.
did I? Can you hear me? Did I froze
Yeah,
or no?
we can hear you now. You're good now.
Okay, okay. Okay, so some of you are I'm frozen, some of you I'm not, okay? Don't worry, I'll play the last two videos, okay? Right, so you see that now the pink area is outside the region where the material will yield, okay? For ductile material, for brittle material, it might even what? Fail, okay? Now, let's find the next point, okay? So we only found one valid point. Okay, so this one is valid. Let's find another point now. Okay, so again, we're going to draw Mohr circle. I'm only going to draw half of the circle now. Okay, sorry, half of the side. Y'all know what the demilitarized zone is fine already. So the next circle.
Did the call crash for anyone else?
I'm okay.
Over here.
Okay. So this will be equal to, maybe it's slower. I think it might be slower, Colin. Okay. So I'm going to start from minus 160, 140, 120, 100, minus 20, 0, and 20. So this is my normal stress. Okay. Then we are going to look at our shear stress. Okay. Clockwise, anti-clockwise, minus 20, minus 40, 60, 80, 20, 40, 60, 80. Okay. Then we still our no-go zone. I'm still going to draw our no-go zone. Okay, so this is our no-go zone. So we cannot go beyond that. Okay. As I say, I'm only drawing half of it. Okay, I don't waste your time drawing the other half, because the circle will not go the other half. Right. So this is one line. 75 line. So it cannot go outside. You go outside, you're dead. The material will yield. Okay. Then we have our stress. So this is minus what? Minus 70. Right? Is it minus 70? All of a sudden my eyes become very blurrish now. Minus 70, right? Okay, so minus 70. Then we will have our 40 line. All right. So for sure, what did not change is point Z is still here. Okay. And then over here, this is my point X. Okay. So one of the possibility is one of the circle on our XY plane. Okay, so this is one possibility. You have to try other possibilities. So one of the possibility is on the XY plane, we are going to intersect our stress minimum. Okay, so the XY plane circle will intersect the stress minimum. Okay, so now we draw one line. Okay, from here to here. Now you realize that this line is not the same as any other line we have drawn because it is at stress the shear stress is equal to 0, right? We did not construct a line that is somewhere around here. Okay, we did not construct a line that's above. Hey, what am I doing? That is above. We did not construct a line that's above here. Okay, we did not do that. Okay, this one touches what? Touches 0 because the first thing that we assume is that the XY plane circle will intersect the stress minimum. Okay, so now we are going to employ the rules of the circle. Okay, we're going to use the rules of a circle. Okay, so we know on the rules of the circle, right? I'm going to copy this point. Okay, and then I'm going to paste, and then I'm going to rotate this by 90 degrees. And the rules of the circle states what? Any point on the circumference of the circle, this has to be what? 90 degrees. Yes or no? So let's look at the rules of the circle. So we did the rules of the circle. Okay, we did the rules of the circle. Right? So I'm going to copy. Then I'm going to come back here. I'm going to paste. Okay. Bloody hell. Sorry. No swearing, Eugene. Right? So the rules of the circle, that is what we have over here. Right? You can see now, too small. Right? Can you see this 90 degrees? Yes or no? Right? Can you see this is 90 degrees also? Yes? So now I construct a line 90 degrees, okay, adjacent from one another, 90 degrees, right? And then now I'm going to call this angle alpha. I'm also going to call this alpha. So why I'm doing that is I want to find, okay, why we are doing that is I want to find the principal stress, okay, principal stress for XY plane circle. Okay, we want to do that. Okay, so alpha is not difficult to find, right? You can find alpha. So tangent alpha. So tangent alpha will be equal to what? It will be equal to 40 divided by 10, 20, 30, 40, 50, 60, 70, 80. 80. Right? So from here, alpha is equal to 40 divided by 80. Inverse tangent is equal to 26.56 degrees. Okay. And then I'm going to call this point out here where intersect. This is my stress C. I'm just going to call it stress C for now. Okay. So I'm going to shorten the length. Okay. So this is my stress C. So to find stress C, right, we know to find stress C, what do we know? We know what is our what? I'll change it to 26.6. It's impossible to measure 5.6, okay? Right. So from here, we can calculate our stress C. Right. So stress C is equal to minus 70. It's going towards the left hand side. So I'm going to use tangent again. So tangent alpha, so 40. Right. Tangent 26.6 degrees. Why? Because the distance from here to here, right, is equal to what? Is equal to 40 tangent 26.6. Okay, so this will be equal. So if you sketch, it's at 50. If we calculate correctly, it should be also be 50. So tangent 26.6 times by 40. Sorry, this is plus. I do apologize. It's going towards the left hand side. So minus 70. So this is equal to minus 50, which is correct. Okay, so this is my term. So from here, right? From here, we can construct one circle now, right? We can construct, so we can calculate our stress average. So center of circle. Okay, center of circle for X, Y plane. So this is stress average on X, Y plane is equal to minus 50 plus by minus 150 divided by 2. So this is going to minus 100 megapascal. Okay. So we know now, right? We know now that our stress average, the center of circle, is at our minus what? Is at our minus 100. Okay, minus 100. So now we can draw a circle. So 20, 40, 50. So it's 100. Okay. So this is our whole circle. Okay, different color. So this is one of your Mohr circle now. Okay. And then from here, right, you can draw a line, right, going through the center of circle, right? So over here, you have just discovered where, over here, right, you just discover your what? This is your possible, your stress Y2, right? This is your stress Y2. So your stress Y2, so now you can calculate your what? You can calculate your stress Y2, okay? So how do we calculate your stress Y2? So we know that the angle between here to here is also alpha, right? So the angle from here to here is 180 minus 2 alpha. This angle over here is your 2 alpha, and this angle over here is also your what? Is also your 2 alpha. Okay, so your stress Y now, or stress Y2, right? So you know your alpha, so therefore stress Y2 will be equal to minus 100, right? Minus 100. Then you will have what? Minus by 40. Okay. Over tangent twice 2 alpha. So alpha is equal to what? Alpha is equal to 26.6 degrees, right? So this will be equal to minus 40 divided by tangent twice times by 26.6, close bracket, minus by 100 is equal to minus by 130. Okay, is it 100? Yep, minus 130 MPa. So this is your stress 2 value. But is the answer valid? Is the answer correct? Right? You have to ask yourself, is this valid?
Doesn't it yield at that point if you find the principal stress of it?
No, the principal stress is still at minus 150.
Okay.
Okay. So the next question is it valid? Is this valid? So does the tau max of 75 megapascal, right, valid. So by observation, can someone tell me, is the radius 75 megapascal? Anyone? Is the radius 75? The answer is what? The answer is not equal to 75. But does the 75 exist? The answer is yes. If and only if you construct 3D Mohr circle. What do I mean? Okay, so now we have to construct 3D Mohr circle. We have drawn 2D, right? Now we have to draw 3D. So now we know that this is your what? This is your XY plane, right? Then you can draw another circle, right? We can sketch another circle. So this circle will be from here, 50, 25. Now, this circle, what plane is it? Anyone? Is your what? XZ plane, right? And then you construct your final circle. Okay, this is your final circle. And based on this final circle, this is your what plane? YZ plane. So when you draw the 3D Mohr circle, right? Right? If and only 3D Mohr circle, you say that this is valid. Okay, so this answer is what? This answer is valid. Okay, makes sense, yes or no? Right? Because you have to satisfy the tau max is equal to what? 150. Okay, so this is your answer. Okay, now if you look at the solution, right? So they have the minus 130. Okay, they have the minus 150 plus 50. We calculate all these, yes or no? And then they say, okay, do you know why it's okay physically? You can't even tell, man. I can't tell. Maybe someone like your math instructor can tell. I can't tell. I'm an engineer, for crying out loud. Okay, so with this, right, that is why I don't want to use the mathematical form or the solution manual. We construct Mohr circle. I did not teach you anything new, did I? Okay, we apply the first 5 pages that we have been through today's lecture, and that's it. Okay, we solve complex problem like this. Okay, you can give us anything on Mohr circle, give you anything on Mohr circle. You just apply the first 5 pages that how I teach you. You understand the mechanics of it. With that note, I'm going to end my lecture now. Okay, so this is the last topic. I'm going to stop recording now. Okay. Hold on.
So our final test